So 7.4 is the last hypothesis test that we will be doing. This one is for proportions. So that means that the main thing that when you read the problems, there will be no mention of a mean or a standard deviation. That's how you know you're going to be working with proportions. Okay. So your problem here's a researcher claims that less than 45% of the US adults use passwords. They're less secure because complicated ones are too hard to remember. In a random sample of 141 say that they use passwords that are less secure. Notice that you've got percentages being used twice. Now, it doesn't always have to be a percentage because they could just, instead of saying 41%, they could have said 41 out of that 100. So they could give you a count rather than a percentage. But that's how we know. Notice there was no mention of a mean and no mention of a standard deviation. So that's how that's how we know that we are dealing with a proportion. And because we're dealing with a proportion, it'll be a one sample proportion. We are going to be using a z value. So that means you're going to probably need your z table. And this is the formula right here. So the difference between the p hat and the p is going to be the number that's written with the claim, and then the p hat will be information about, this will be information that's written in the claim. This will be about the sample. Okay, so they'll be telling you about the sample. This notice down here is not p hat, it's this p. So be careful that you keep these two pieces of information separate from each other, the difference between p and p hat. Okay, so if you're going to do it by hand, these are the steps for doing it by hand. Here, we don't have to worry about our sample size being greater than 30. We have to check and make sure that the proportion or the number that's in the sample multiplied by the value of p, that has to be greater than 5, and so is the same thing about q. Remember, that what's the relationship between p and q? Q is equal to 1 minus p. So P and Q should always add together to be 1. P plus Q should add together to be 1. All right. So you do need to check and make sure that this happens. It should always happen. I don't think that I've ever given one where it didn't happen and you had to say, oh, I can't work this problem. You're going to state the claim and then determine whether the claim is the null hypothesis, which contains equality, or the alternative hypothesis, which does not. There will be a critical value that goes along with the alpha. So as you can see right here, here's the critical, it says pay attention to the alpha, and then here's the critical value. Then you find your rejection regions, find your test statistic. If you're doing it by hand, this will be the formula that you'll use, and then you make a decision and interpret the results. Okay. So pretty much the exact same process that we've been doing. So it shouldn't be any different. You can do Stack Crunch on this, and you can do the calculator. So I'm going to do those separate. We will do this one by hand. Okay. So here is the claim. The researcher claims. So your claim is that, and remember, this right here is a proportion. Okay. So this is 0.45. So the research claims that less than 45%. So the claim is going to be, it's always about P. Remember, the claim is always about P. So P is less than 0.45. Okay, so now that's the claim. Claim that P claim that P is less than 45%. P is less than 45%. Does that contain equality? No, it does not. So since it does not contain equality, we label that the alternative hypothesis. Now, what's the opposite of P being less than 0.45? Well, the opposite of that would be P is greater than or equal to 0.45. Okay, this one does contain equality, so we're going to label that the null hypothesis. Okay. You look at the alternative hypothesis to determine that this is a left tail test. So when you draw the picture for the rejection, you know where to draw it. Okay. And this is a Z. And why is it a Z? Because we have Z's when we're dealing with proportions. So this is 0. It's a left tail test because it's less than. So we're going to be dealing with this shaded section over here. Okay, and this alpha is 0.01. So we need our critical value, which is a Z value, our critical value for this area right here. You can use StatCrunch by putting this in the area section of the normal distribution, or you can use the Z table by looking this number up. Or you can use the calculator and do an inverse Z. And this will be the area that you put in the calculator. I'm going to go ahead and pause the video right now, and almost stop it. Because one, I think I've been talking close to 10 minutes, and two, I have an email that I need to check. And three, this is as a good time as any. So see if you can go ahead and find the critical Z value by either using, and I don't care which one, the table, StatCrunch, or the calculator.